Hi all, I am here with my new video on formulas, equations and chemical reactions. Let's start. In this video, we are going to learn about writing and naming chemical formulas. First, we learn about how to write formulas for ionic compounds. When we write formulas for ionic compounds, we keep in mind that all compounds are electrically neutral. So the total electric charge on an ionic compound must be zero. The total charge on the positive ions equals the total charge on the negative ions. We place positive ion first and negative ion second. Examples of ionic compounds naming. Ionic compound potassium fluoride Kf contains positive potassium ion and negative fluoride ions. Since both ions have equal positive and negative charge, formula would be Kf. Another ionic compound that contains lithium Li plus and O2 minus ions, the ratio of positive ions and negative ion is 1:2. So writing formula for this, we need a common total charge for both positive ions and negative ions. If we obtain a charge of 2, a number that is both divisible by 1 and 2, so formula would be Li2O. It's problem solving time. Our first problem is write the formula for the compound that contains positive zinc ions Zn2 plus and negative phosphate ions PO4 3 minus. Our second problem is determine the charges in the compound Ag2S. The solutions are on the next slide, but you can try to solve these problems yourself. Here is the solution for our first problem, which was write the formula for the compound that contains Zn2 plus ion and PO4 3 minus ions. The ratio of charges on Zn2 plus and PO4 3 minus ion is 2:3. In order for the compound to have a total charge of 0, we multiply 3 and 2 and obtain 6 to get a minimum common divisible number for both the ions. Since zinc has plus 2 charge, when we divide 6 by 2, we get 3, and this is the number of zinc ions in the compound. Similarly, for phosphate ion, it has minus 3 charge. So when we divide 6 by 3, we get 2, and this is the number of phosphate ions in the compound. So formula for this compound would be Zn3PO4 whole twice. Our second problem was determine the charges in the compound Ag2S, which is completely opposite to our first problem. For this, we refer to the periodic table and look for silver Ag. Ag is located in group 11 and its ion has charge of +1. And sulfur S is located in group 16 and its ion has charge -2. Since we have two Ag ions, so we compensate the negative 2 minus charge. There must be +1 charge on each Ag ion. So here positive ion would be Ag plus and negative ion would be S2 minus. Naming binary ionic compounds. We name a binary ionic compound by combining the names of the two elements that make up the compound. Positive ion is placed first and then negative ion and the suffix "ide" added at the end of the name. Example, NaCl is named sodium chloride. IUPAC International Union of Pure and Applied Chemistry System. Many metallic elements can have more than one positive charge. For example, iron, Fe, exists as Fe2 plus and Fe3 plus ions. Therefore, it can make two oxides, FeO and Fe2O3. To name this compound, as the charge of iron varies, we provide iron with a Roman numeral in parentheses, which corresponds to its positive charges. Therefore, FeO is given name iron second oxide and Fe2O3 is given name iron third oxide. If a metallic ion has only one charge like sodium ion, Na+, no Roman numeral is used in the name. This method of naming compounds is known as IUPAC, which means International Union of Pure and Applied Chemistry System. On this slide, a list of some elements with negative oxidation numbers and their names ending is given. Problem solving time. Our first problem is write the formulas for the following compounds: A. Copper second sulfide, B. Tin fourth oxide, C. Aluminum nitride, D. Iron third bromide. Our second problem is name the following compounds: A. MgF2, B. KH, C. NiI3, D. V2O5. The solution are on the next slide, but you can try to solve this by yourself. Solutions. Solution for problem 1, copper second sulfide CuS, tin fourth oxide SnO2, aluminum nitride AlN, iron third bromide FeBr3. Solution for problem number 2, A MgF2, magnesium fluoride, B KH, potassium hydride, C NiI3, nickel third iodide, D V2O5, vanadium fifth oxide. Naming compounds that contain polyatomic ion. Naming of an ionic compound that contains a polyatomic ion is same as naming ionic binary compound, but you need to recognize that a polyatomic ion is present in the compound. For example, polyatomic ionic compound K2SO4 is named potassium sulfate, NaNO3 is named sodium nitrate, Fe parenthesis open C2H3O2 parenthesis close 3 iron third acetate. Here C2H3O2 minus is acetate ion and Fe3 plus is iron third. Writing formulas for molecular compounds. Atoms in molecular compound do not have real charges like ions do in ionic compounds. Nevertheless, atoms are electrical and they can do behave as though they possess charges. The type of charge in molecular compound is known as apparent charge. So the concept of oxidation number is developed to work with both real and apparent charge. An oxidation number can be positive, negative or zero. When we write an oxidation number, we place sign before the number itself like +2. This distinguishes oxidation numbers from actual charge in which the sign is placed after the numbers like 2 plus. There are 6 simplified rules for assigning oxidation numbers to elements. First, the oxidation number of every atom in free element is 0. By free element means atom that is not combined with another element. For example, sodium, helium, oxygen are free elements and each of the atoms that comprise them has an oxidation number of 0. In a molecular or ionic compound, the algebraic sum of the oxidation numbers must be 0 since all compounds are electrically neutral. The oxidation number of a simple ion is its charge. For example, in negative chlorine ion, oxidation number is -1 and in Cu2 plus, the oxidation number is +2. In a polyatomic ion, the algebraic sum of the individual oxidation numbers must equal the charge on ion. Hydrogen in combination usually has an oxidation number of +1, exception hydrides where hydrogen has an oxidation number of -1. Example, sodium hydride NaH. Oxygen in combination usually has an oxidation number of -2. Exceptions in peroxides H2O2 where oxygen has an oxidation number of -1 and oxygen fluorine compounds where oxygen has positive oxidation number. To write formulas for molecular compounds, the rules are following. First, elements with positive oxidation numbers generally precede elements with negative oxidation numbers. Second, the algebraic sum of the oxidation numbers must be 0. For example, sulfur can combine with oxygen to form two compounds. Since oxygen must have an oxidation number of -2, sulfur must have positive oxidation numbers. Referring to the periodic table, sulfur has two positive oxidation numbers, +4 and +6. So the two possible formulas are SO2 and SO3. Problems. Write the formulas for the binary compounds corresponding to the following combination of elements A, N and O, B, P and Cl, C, H and S. Solution for our problem is following. First, N and O. There are 5 possibilities N2O, NO, N2O3, NO2, N2O5. P and Cl, PCl3 and PCl5, C, H and S, H2S. We can do same backwards. If a molecular formula is given, we can determine the oxidation number of each element in the compound. We can also do this for a polyatomic ion since the atoms within the ion behave pretty much as those in a molecular compound. They share electrons. Examples are following on the next slide. Problems. Find the oxidation number of each in the following elements. A. Iron and chlorine in FeCl3, B. Chromium in Na2Cr2O7, C. Sulfur in H2SO3. Our first problem is oxidation number of iron and chlorine in FeCl3. We must rely on the fact that chlorine will be negative in this compound. According to the periodic table, the negative oxidation number of chlorine is -1. So in FeCl3, the oxidation number of chlorine is -1. The total negative oxidation number is 3 multiplied by -1 is equal to -3. For the compound to be electrically neutral, positive oxidation number must be equal to negative oxidation number. So the oxidation number of Fe, iron in FeCl3 will be +3. Next problem is find oxidation number of chromium in Na2Cr2O7. To solve this, first we find out the oxidation number of all the atoms. The oxidation number of sodium is +1 and there are 2 sodium atoms. So total for sodium is 2 multiplied by 1 is equal to +2. The oxidation number of oxygen is -2 and there are 7 atoms of oxygen. So total for oxygen is 7 multiplied by -2 equal to -14. Note, to be electrically neutral compound, negative oxidation number must be equal to positive oxidation number. So to calculate the oxidation number of chromium, we will add the oxidation number of both atoms. +2 minus 14 equal to -12. The positive oxidation number must be +12. Since there are 2 atoms of chromium, so we divide 12 by 2 equal to 6. So the oxidation number of chromium is +6. Our next problem is to find oxidation number of sulfur in H2SO3. The oxidation number of hydrogen is +1 and there are 2 hydrogen atoms in H2SO3. So total for hydrogen is 2 multiplied by +1 equal to +2. The oxidation number of oxygen atom is -2. So total for oxygen is 3 into -2 equal to -6. To calculate the oxidation number of sulfur, we will add the oxidation number of both the atoms. -6 plus 2 equal to -4. To be electrically neutral compound, negative oxidation number must be equal to positive oxidation number. So the oxidation number of sulfur will be +4. In our next video, we are going to learn about chemical equations. Please like and subscribe to watch new videos. Thank you for watching and bye bye for now.